Hello everyone, I am Anna and we are from Group 5. My group consists of me, Anna, Ajal, Isa, Farina, Aisha Najwa, Izzat Zarfan and Farid Reza. Today, we are going to explain about our MAT097 assignment. The title of our presentation today is Growth of South Korea. So our assignment consists of two parts, which are task 1 and task 2. Firstly, I am going to explain about our task 1, which is application of first order differential equations. So we had chosen the growth of South Korea to be the data for our first task, and here is our tabulated data. As shown here, we took the population data of South Korea from the year 1992 to 2011, and the population is increasing. Hence, we chose growth of South Korea but not decay. And the source of our population data is from worldometers.info website. And the reason we had chosen the year 1992 to 2011 is because starting from 2012, the population is slightly decreasing and we are doing growth of South Korea instead of decay.
Next, to analyze South Korea's population trend, we plot two comparative graphs, which are the population of South Korea from 1992 to 2011 and the graph of a particular solution. We also compare both graphs together. According to the figure 1, the population of people in South Korea is increasing with time in terms of years. Based on figure 1, the population of South Korea is the highest in 2011 with 49,127,403 people compared to previous years. Next, figure 2 shows the number of population particular solution of people in South Korea from 1992 to 2011. As we can see, the particular solution gives an exponential graph as the basic graph. According to figure 2 also, the graph of a particular solution for the number of people in South Korea is directly proportional with time. When time is increasing, the number of people in South Korea is expected to increasing too. Hence, it is predicted that the population of South Korea will be higher and keep on increasing in the future. Last but not least, figure 3 shows the graph of comparing the value, actual and estimated number of people in South Korea by time. We examined from figure 3 and found that the estimated and real number of people increased rapidly. When we compare the estimated numbers to the actual value, we can see that there are variations. As a result, there exists mistake, and we think that several elements and reasons contribute to the data divergence.
Our particular solution is 44,653,695 e to the power of 0.00523t. Our feature value is from 1994, as we took 1992 as the 0t. Making 1994 as the second t, this makes it easier to compare with the value from the particular solution than actually taking a future value that hasn't been calculated. And the past value is from 1991 with t being -1. Next, we will discuss the accuracy of the values calculated using the particular solution by comparing them to the actual values and analyzing the percentage error of it. First of all, are the values calculated from the particular solution accurate with the actual values? So, as shown in the slide, the calculated values are indeed very close to the actual value. This indicates high level of accuracy in our calculations. However, as precise as they are, there are still small discrepancies when compared with the true values. This is how we calculated the percentage error. So these values confirm that the percentage error are extremely small, which is 0.02% and 0.04%, indicating that the model is highly reliable.
Some factors of population growth is due to modernization, as people started going to school for education and working to earn money. They could afford to start a family. Moreover, another factor is the price of things were a lot cheaper than now in terms of housing, food, and daily life stuff. This is called deflation. Now, I think some factors that would affect the population in the future are access to the medical care. With the increase of government hospitals and clinics, people who are sick are able to afford the medicines and the care that they need. This in turn can extend our life expectancy. Besides that, I think migration also plays a huge part. This is because as our obsession with a certain culture increases because of online exposure, this can interest some people to move to that country instead of staying on their own home country. For example, for South Korea, people are obsessed to K-dramas or K-pop, that so much so that people are willing to migrate to South Korea to meet their idols easily. Lastly, the other factor would be inflation, which increases the cost of living. This would deter people from marrying and having kids, as it would cost a lot to pay for their expenses. Therefore, our birth rate might not increase.
For the conclusion part, all things considered, Task 1's goal have been completely met. We comprehend completely the application of first-order differential equation from MAT097 course to our project. Using this strategy, we were able to determine the increase in population of South Korea from 1992 to 2011 in Task 1. In addition, we also identified the real factors that cause increase in population. One of the benefits of Task 1 was that it allowed us to apply mathematical techniques such as the Malthusian model, which is derived from first-order differential equation to solve problem in a realistic manner.
Moving on to task 2, the question for our group is to find the integration of the equation 3 minus x power of 2 power of x divided by x plus 2 using the trapezium rule using 7 and 9 subinterval. First of all, what is trapezium rule? The trapezium rule, also called as trapezoidal rule, is a numerical method used to approximate the area under a curve, or more precisely, the definite integral of a function over a certain interval. Instead of calculating the exact area under the curve, the trapezium rule approximates it by dividing the area into trapezium and then adding the areas. The formula for this rule is this, where delta x is the width of each interval and n is the number of interval. So, for our question, we are required to do two subinterval, which is 9 and 7. We solve the question by using Microsoft Excel. Firstly, we search for the delta x by using the formula, and the first column x with the value -3/4, as it is the limit, will be added with the value of delta x that is found until it reaches the end limit, which is 15/4. Since our question is a bit complicated to solve with exponent present, we decided to divide the column of the x into multiple parts to ease the calculations. So, for the coefficient part, the reason why it is 1 at the first and last value and 2 for the value in between is because the first and last point are only used once, while the middle points are shared between two trapeziums. That's why in the formula, the first and last value have a coefficient of 1 and the middle values have coefficient of 2. Lastly, the coefficient and the fx values are multiplied, and the sum of it all will then be used to find the approximate area. The formula of trapezium rule is applied, so the delta x will be divided by 2 and then will be multiplied by the sum of fx and c.
Now, I will explain how to solve the given integration problem using the trapezium rule with 9 subintervals. The problem asks us to approximate the area under a curve between -3 quarters and 15 quarters. To apply the trapezium rule, we first divide the interval from -0.75 to 3.75 into 9 equal parts. We calculate the width of each subinterval by subtracting the lower limit from the upper limit and dividing by 9. The result is 0.5, meaning each subinterval has a width of 0.5. Next, I list all the x values starting from -0.75, increasing by 0.5 each time until I reach 3.75. At each x value, I substitute into the function, which is 3 raised to the power of 2 to the x divided by x plus 2. This gives me the function values for each x. According to the trapezium rule, the first and last function values are taken once, and all the middle function values are multiplied by 2. I then add up all these adjusted values. The total sum I obtained was 43.5957901. Finally, to find the approximate area, I'll multiply the total sum by half of delta x, which is 0.525. Multiplying 0.25 by the total gave me the final answer of 10.8989475. Rounded to 7 significant figures, the final answer is 10.898948. On the graph, you can see the trapezium that approximate the area under the curve from negative 0.75 to 3.75. That is how I applied the trapezium rule with 9 subinterval to estimate the value of the integral.